Good morning, everyone. Any questions as usual? Nine and 11. Which section, Chris?
The polar coordinates one.
12.1 or 12.2? No, I meant 12.12, 12.2.
Let me check, but I'm assuming 12.2 because considering it's the second, it was like the second part of the assignments.
Okay.
But let me check just in case.
Let me. All right, so I will check Zach problem 12.1 while I think Chris, you mean 12.2 definitely. 9 and 11. Okay. All right. So I will look at
12.2.
Yeah. Number 79. And then I'll proceed to 12.2. We're going to do other problems along the same line. So we don't, 9 and 11 will be fairly simple. So let me look at 79. Okay, so we have x equal 1 plus 1 over t. So we have a curve, and y equal t minus 1 over t. And okay. Again, so we have a curve. I don't know how this curve look like. It's not very hard to find it. I mean, it's not, this is a curve where finding an equation relating x and y is not impossible, it's actually feasible, but we don't have to worry about that. They want us to find a point where the slope is 1. So basically, we're going to find the slope, set it equal to 1, and solve for t. The first thing is that since x is a function of t and y is a function of t, so for the slope here, which is basically dy dx, is given by dy dt over dt dx dt. Okay, so it's even the formula is easy to memorize because basically it's, I mean, intuitively you simplify dt, you get the dy dx. Sorry. So it's equal to, let us find the derivative of each one. The derivative of y with respect to t is 1. The derivative of minus 1 over t is 1 over t squared divided by derivative of x 1 over t squared. So this is going to be equal to, so a common denominator in the numerator, to simplify it a little bit, I will have t squared plus 1 over t squared, and this will leave me with t squared plus 1 after a little bit of algebra. All right. Now, when is the slope equal to 1? So we're going to find the t first, such that the slope equal to 1. So it's basically we set and solve for t. Okay, so we set the slope equal to 1 and solve for t. So t squared plus 1 equal to t, it means t squared equal to 0, t equal to 0. Okay, now, here's the question. If t equal to 0, x is 1 over 1 plus t. It means it's not defined. Y is t minus 1 over t is not defined. So the slope would be 0 if t equal to 0. But for t equal to 0, there is no x and y because of their definition. So the answer would be there are no points such that the slope is 1. We cannot find a point. No matter what the curve is, there is no point. And simply because x and y are not defined for t equal to 0. So it's a curve where the domain of t, it means the value that we're allowed for t is t has to be definitely non-zero. Because t equal to 0, x and y do not make sense whatsoever. Okay, question before I move on? Very well. So now let's go to polar coordinate, and definitely we're going to address Chris's question with different points. So back again, if I move the paper without too fast, let me know. So back to polar coordinate. And yesterday we introduced them and as a different way of locating a point in the plane. And we sketch some points. So let us say if you want to sketch the point with polar coordinate. First, I'm going to take positive one. Let us say 5 minus 2 pi over 3, let us say. Okay, so this point is the following. This is the r, and this is the theta. Okay, minus 2 pi over 3, it means minus 120. It means we start from here, and we're going to go 2 pi over 3 this way, and then 5 units from here. So this will be the point. Remember, negative theta, it means we go in the clockwise direction. So this is the point 5 minus 2 pi over 3, and of course in polar. And then we extended the meaning of r to allow r to be negative. It means we're going to allow the r, which is negative. From the definition, the first definition I gave yesterday, r cannot be negative because it is the distance from the origin to the point. But now we're extending the meaning as follows. So let us recall that minus r theta and r theta, so that's our definition going to be, are the reflection of each other with respect to the origin. So let us explain what I am talking about. A reflection of each other with respect to the origin. So graphically, that's what r theta and minus r theta are with respect to each other. If this is r theta, minus r theta is right there. Okay, totally the opposite. All right, so let us do some bunch of examples to understand exactly what a negative r is about. So we're going to sketch a bunch of points. So this will become fairly clear. All right, so sketch the point with the following polar coordinate. All right, sketch the point. So as you realize, I'm trying always to tell you that these are polar, so we know that difference between them and Cartesian. So we know that we're dealing with polar. Sketch the point with the given polar coordinate. Okay. So first point that I sketch is minus 4. So that's at the polar. So it means that's my r, which is negative here, and 2 pi over 3. And that's the theta. So r is negative. So how do we sketch a point in polar coordinate? The r is negative. The way we sketch it is like this. First, we sketch the one with the positive r for 2 pi over 3. So this is 2 pi over 3. And this is the 4 2 pi over 3. That's the positive r. The negative one is just you take that and you draw the reflection with respect to the origin. This is the point. This one is the one with the negative r. That's the one I am after. Minus 4 2 pi over 3. Okay, that's the definition of negative r. So first we draw the one with positive. Then we take its reflection with respect to the origin. We get the one with negative. So that's the definition of a negative r. So we're going to take 2 more points. So this idea will become fairly clear. So now I'm going to sketch the point that I say minus 3, 5 pi over 4. Okay. Again, first we sketch the one with the positive r. So it's the 3, 5 pi over 4. Now 5 pi over 4 It means gonna put me right there. So this is the theta. That's the 5 pi over 4. And this is the one, the positive one. That's not my point. That's the 0.35 pi over 4. The one with the positive r. It means from here to here, I have r. The one I'm interested in, the one with the negative r, is this point right there. This is the negative 5 pi over 4. So that's really the point I am interested in. So my last one. So as we realize, it's the following. If r is negative, the point is in the quadrant opposite to theta. So if theta is 2 pi over 3 in this quadrant, when r is negative, the point is in the opposite quadrant. So right here, the 5 pi over 4 is in quadrant number 3. When r is negative, the point ends up in the one opposite to it, which is quadrant number 1 in this case. Now finally, let me take, like let us say -3 minus pi over 4. In which quadrant is this point going to end up? In which quadrant this point will end up? I'm listening. In which quadrant? In the fourth quadrant? Think a little bit.
Second.
In the second quadrant, exactly. In the second quadrant. Okay, so let's draw it one more time. Minus pi over 4 is here. So the positive 3 minus pi over 4 is here. The negative 3 is going to be exactly right there. So it's going to be in the second quadrant. That would be the one with the negative pi. All right, so it's not the fourth quadrant is the one with the positive 3, but that's not my goal. My goal is the one with the negative 3. The one with the negative 3 is going to be the fourth quadrant. So let me give you one more. We're not going to draw it. I'm just going to ask you which quadrant do you think is going to be. Suppose I give you -3. It doesn't really matter. And I don't know, 5 pi over 3. Okay. All right. In which quadrant this point would be? Remember, pi over 3 is almost 60.
Second.
In which quadrant this would be? Okay, well, why it's the first?
I misread that. I thought it was 5 pi over 4.
Oh, okay. So which, yeah, no, all right. I changed it. So which quadrant do you think it's going to be?
It's actually going to be the second.
Exactly, it's going to be in the second quadrant. Okay, so 5 pi over 3 is like 300 degrees because this is 60. So 5 pi over 3, so it's going to go. So this is the positive one. To be very careful, I'm drawing the positive one first. But that's not what I want. The one I want is this reflection. So it's going to be in this quadrant, in the quadrant 2, in this scenario. That's the -3, 5 pi over 3. Okay, with this now, we're going to allow R to be positive and to be negative. There will be no more restriction on R using this definition. Now, in Cartesian coordinate, Cartesian, every point has a pair of coordinates. And this pair of coordinates is unique. It means in Cartesian, a point does not have only one pair of coordinates. If this is 2 and this is 3, this is 2, 3. No question asked. When you put points in polar, the points can have a lot of, or I would say different representation in polar coordinate. But the representation is not unique. Because every point can have several representations. So we're going to work along the same line. But first, let me, since I'm working with our negative a little bit, who can give me another representation for this point in polar coordinate? So this point right here, we which is, this is one representation, who can give me another representation. It means another way to represent the point using polar coordinates. So another representation is I don't know if you guys are understanding the question I'm asking. Okay, so we're going to do a lot of problems to talk about the idea of another representation of a point. So let's do that. Okay. Right, so I thought was an easy point because the one I did is a little bit harder. Let's start with an easy point. So find, my question is, find two representation. What I mean by representation, it means two different polar coordinates for the same point. Find two different representation in polar coordinate of the following point. 2 and pi over 3. I want two different representation. One with R positive, one with R negative. Okay, so this is my point 2 pi over 3. First I sketch it. R is positive, so I don't have any issue here. Pi over 3, it means I start from the positive x-axis and I go pi over 3, which is 60. And then I move 2. So that's already the point. Okay, okay, give me another pair of polar coordinate that represent the same point with R positive.
Would it be 2 and then negative 5 pi over 3?
Negative 5 pi over 3. So how did you get the negative 5 pi over 3?
Well, I knew we had to go the other way, and so I just subtracted 2 pi from...
Okay, so he went the other way, this way. Basically, he's looking at this angle, right? Is the dotted line what you're looking at?
Yeah.
Yeah. So this angle is, all right, that's absolutely correct. So he said it's pi over 3. You take away 2 pi. So one representation is pi over 3 minus 2 pi, which will give me exactly the same point. And this is pi minus 5 pi over 3. So that's a representation. Or instead of going backward 2 pi, why don't we go forward 2 pi, which is even easier. So if I take pi over 3 and then I add 2 pi, there are a lot of them. There are infinitely many ways. That's another representation for the same point. So, or I can take pi over 3 plus 2 pi. It means 7 pi over 3. 7 pi over 3. Okay, that's another representation. Still, I am with R positive. And if I want more representation, I keep adding 2 pi's or subtracting 2 pi. The point is not changing at all. So there are infinitely many. I can take pi over 3 plus 4 pi, plus 6 pi, plus 8 pi, or minus 2 pi, minus 4 pi. They all would represent the same point. So there are really infinitely many representations of a point. All right. So with R positive, no question asked. It's not hard. What about with R negative? So can you give me a point, a representation of that, where the R is negative? So here, positive R. Okay, now I'm going to do the same one, but negative R. And I'm going to draw the point again so that we can draw stuff. So it's the same point. That's the pi over 3. From here to here is the 2. And this is 2 pi over 3. I want another representation where the R is negative. Anybody?
-2 4 pi over 3.
Okay, you have to tell me where you got the 4 pi over 3.
Well, I just thought on the unit circle, isn't it all like the reverse power? Isn't 4 pi over 3 the reverse of pi over 3? Like on the other side. So once you go that side, you have to go all the way back for reverse for -2.
Yeah, so you're looking at this point, right?
Yeah.
Okay, so what is your angle? It's pi over 3. How much did you add to it? How did you get 4 pi over 3 from pi over 3?
Oh, okay. Okay, never mind. Okay, never mind.
Understand? But how did you get it?
Yeah.
It's pi over 3. How much do you add? How much did I add? What's the angle from here to here? It's pi over 3.
Oh, isn't that just 180?
Yeah, or pi. Yes, because we work in radian. And that's pi or 180. So now this angle, the whole thing from here to here, is pi over 3 plus pi, pi over 3 plus pi. This is the 4 pi over 3 you're talking about. So I look at this point. This point is 2, 4 pi over 3. So a representation for that would be -2, 4 pi over 3. Okay, so I repeat a little bit the picture. I want 2 pi over 3. I want the representation with a negative r. So I say, okay, let me take the one which is totally, it's reflection, this one. This one is, I take the positive r for this one. It's 2. And the angle, if this is pi over 3, I'm going to add pi, which can give me 4 pi over 3. So this one is going to be -2, 4 pi over 3. So a negative representation, -2, 4 pi over 3. Where the 4 pi over 3 is actually nothing more than the pi over 3 plus pi. Pi over 3 plus pi give me totally the reflection with respect to the origin. Okay, I'll give you another point. I want all of you to be able to give me the representation. So now what we did is basically we took the one, this reflection. To get that, we add pi. We get this point, and then we went back and we took the -3. So I'll give you 1 point, and all of you please try to, so same question for the following point. For the point 2 minus pi over 6. Okay. Again, I want first r positive, and then I want r negative. And without a picture, I personally don't work very well. So this is -5 over 6, and that's the point given to us. Okay, all right, I want the first one as quickly as you can with a positive r, another representation. So I want positive r, this has to remain 2. It's the angle with the changing. The 2 cannot change. From here to here, this cannot change. All right, what angle?
11 pi over 6.
What?
11 pi over 6.
Okay, it basically is looking at that. This angle right there. And what's this angle right there? It's basically the 2 pi minus the pi over 6, which is 11 pi over 6. So it's very, very picture oriented. 11 pi over 6. That's one of them. Now, if you take 11 pi over 6 and you add 2 pi, then you get another one, because actually what you're doing is, this is 11 pi over 6. You're adding 2 pi. It means you are going around the circle another one. You're going around one more time. Nothing will change. All right, now r negative. I want a negative r. So basically it has to be -2. It is the angle that it's the one we want. And use the picture. I mean, totally use the picture, because whatever your answer you give me, you have to explain it.
-2 pi of pi, or 5/6 of pi.
I have to write it down. I didn't follow. Go ahead.
5/6 of pi.
5 pi over 6.
Mm-hmm. Yeah.
Okay, how did you get that?
The opposite angle. You can draw that, yeah. Out.
Right there.
Instead of, yeah, 5,
Exactly.
6 pi.
Absolutely correct. So he drew this point. That's the positive R, and then he has to figure out the theta here. But now the picture, of course, suggests that this angle here is pi over 6. I mean, we're just using basically the picture. So this going to be pi minus pi over 6, which is the 5 pi over 6. So this is 5 pi over 6. So this one, another representation, is going to be the -2 5 pi over 6. Okay, so this is going to be 5 pi over 6. All right, so that's how we do for negative R. First, we take the reflection. We find the reflection was the positive R, and then whatever we find here, we find the angles, and we take the -2 5 pi over 6, which would give me the one with the negative R. So that's how we find different representation of the same point, whether we want R positive or want R negative. The idea is that there are a lot of representation. It's not unique. And that's one disadvantage of the polar coordinate, but it has so many advantages that it makes it very important. So in general, I want to ask this following question. And so let us know that minus R theta is the same point, and tell me if I am right or wrong, as R theta plus pi. Is this correct? No, I think you have more flexibility with that. Is this a correct statement? Minus R theta is the same point as R theta plus pi. Is this a correct statement? What do you think? Think always geometrically. If I have minus R theta, so this is theta, let us say, and that's the positive R theta, minus R theta is going to be here. Is it the same as you realize, minus R theta is actually, if you look at the picture from here to here, that's the pi. So this point is minus R theta, and another representation for it is R theta plus pi. Okay, so minus R theta and R theta plus pi basically represent the same point, different. Part 2 is the following. We studied Cartesian and we studied polar. So every point in the plane now has two sets of coordinates. Every point in the plane have two sets of coordinates. I take a point, and this point has two sets. It has the x and y coordinate, the Cartesian, and it has the polar, the r and the theta. So, and this is the picture. This is the theta, this is the r, and this is the x, and this is the y. So now the natural question would be, if I know the r and theta, can I find the x and y? And if I know the x and y, can I know the r and theta? So the idea is that how can I convert from one coordinate system to another coordinate system? So part 2, from polar to Cartesian. Okay. Basically, suppose we know, so we're given r theta. And the question is, what is the x? What is the y in terms of r theta? Okay, anybody can figure it out. Use a lot of trigonometry in those problems, really basic trigonometry. How can I find X and Y in terms of R and theta?
To find y, you could do r sine theta, I think.
Right, because if you, I'm going to show you Y in the first quadrant, but whatever I say hold, whether theta is in the first, second, third, fourth, whether R is positive or negative. But you're just going to know it in the first quadrant, so you guys can always memorize it very easily. All right, if the first quadrant, as your classmate said, if you look at the sine of theta in the first quadrant, this Y over R, the first quadrant. So this tells me that the Y is always R sine theta. Okay, so we get the Y very easily. And the X, we take the cosine, which is the cosine of theta is the X over the R. It means X is R cosine theta. Okay, so very simple. If I know the R and the theta, I know X and Y. And as I said a minute ago, it holds, those relationships hold whether theta is 1, 2, 3, or 4th quadrant. This relationship hold whether R is positive or negative. So it holds all the time. So a very, very quick example for that. Find the Cartesian coordinate of the point with polar coordinate, to find the Cartesian coordinate of the point with polar coordinate, anything you want. So let us assume the polar coordinate is 2 pi over 3. Right, so I have, this is my point. We always sketch to at least to make sure our answers make sense. So 2 pi over 3, it means we have right there. This is 2 pi over 3. And this is the 2 from here to here. And my question is find the X and find the Y. Okay, so we apply verbatim the formula. X is 2 cosine 2 pi over 3, which is 2 times. Now, what's the cosine of 2 pi over 3? So if this is 2 pi over 3, the cosine is going to be, I think, minus a half, which is a minus 1. And the Y, so this is going to be the minus 1 here, is 2 times the sine of 2 pi over 3. And we know at least it's a positive number. Now the sine of 2 pi over 3 is the square root of 3 over 2, which would give me the square root of 3. So the coordinate are minus 1 square root of 3 Cartesian. Okay, so it's a fairly simple. So this is the square root of 3 right there. Okay, so at this point, have two sets of coordinate, Cartesian, minus 1 square root of 3 Cartesian, polar, it is the 2 pi over 3. So every point now have two sets of coordinates. Right, now how we go from the other way around. So this is from polar to Cartesian is actually fairly simple. Now, part 2 is from Cartesian to polar. Again, I advise you in those problems. I mean, this is nice to memorize because it's really, you're going to be using it tremendously. So this is actually crucial to memorize. Now, from Cartesian to polar. So if I know the Cartesian, how do I get the polar? So from Cartesian to polar. Okay, so here we're given xy. And we need to find the r and the theta. So again, I will draw the picture because as I said over and over, draw the picture because it's trigonometry. It's nothing deeper than that here. So this is my angle theta. And this is my r. And I know x. And I know y. So this is what I know. Okay, how can I find r quickly? Anybody, how can I find R? Let's
Pythagorean
look at the
theorem.
picture. What?
Pythagorean's theorem.
Pythagorean, what does it tell me?
It would be x squared plus y squared equals r squared.
Yeah, we're done with R. Okay. Now, how do you think I'm going to find theta?
Inverse tangent.
Okay, so tangent theta equal to y over x, right? Make sense? Okay, but this one I'm going to set, use it with a lot of care. Use it with care. And I will explain in a minute. And usually my advice to you is to find theta, basically use trig. Don't use any formula. But this is the formula that is in every book, so I wrote it down. But usually I want you to use anything under the sun you want to find theta. You don't have to use this formula. All right, but I said use it with care for a reason. So I'm going to take two problems to actually tell you why I want you to use it with care. All right, so example number one. The question is find the polar coordinate. So I'm going to give you find polar coordinate. Right. So my first problem is a simple one. I'm giving you the Cartesian. So, and I'm asking you the polar. So this is 3, 2. That's the point. And I want you to find the polar coordinate. Step number one, you have to sketch the point. So I will write this in red. Start by sketching the point. If you don't sketch the point, you're going to do a lot of mistakes. So first, sketch the point, especially from polar, from Cartesian, sketch the point. Okay. So I'm going to sketch the point. Those are Cartesian. So we have to be very careful now. So this is the X and the Y. Okay, so this is a 3, 1, 2, 3, and 1, 2. Okay. So that's really the point. Right? So theta, this is my theta. So my theta is in quadrant 1. Okay, now we find the R. So my R is nothing more than we look at the picture. Honestly, just look at the picture. So we know that R squared is X squared plus Y squared, which is 9 plus 4 equal to 13. And let us take the positive R. So we're going to take R equal to the square root of 13. Okay. Now, theta. So this is theta. This is your theta. As I said, use trigonometry. I mean, you don't have only to use the tangent. You can use the sine. You can use the cosine. I don't actually care. If you're just finding the angle theta, that's really what it boils down to. Now, in this problem, using the tangent is easy because it is it's the 2 over 3, the y over the x. It means the theta is the inverse tangent of 2/3. And we are working in radian. Tangent inverse of 2/3. I have no idea what this is. It's something, it's a number. It's a certain angle. And if we plug it into our calculator, we get, 0.588 radian. Now it's almost half a radian. Now a radian is almost 57 degrees, though this should be almost 30 degrees, 33 degrees, something around that much. Okay. So in polar, my point is square root of 13, that's the R, and the tangent inverse of 2/3. So it means this angle here is the 0.588 radian, which is almost 30 degrees, a little bit more, 33 degrees or so. Okay. Now example number 2. I'm going to take the following point, -3, 2. So that's Cartesian, and I want to write it in polar. I want to find its polar coordinate. So as I said, sketch the point first, and localize your theta, sketch the point. Okay. So this is my point here. -3. and it too. Okay. So that's the point right here, and that's the theta. So theta immediately is in which quadrant here?
2.
And you will know in a minute why I'm a little bit picky about that. So first R squared. There is nothing about R squared. So this is my R here. So R squared is -3 squared plus 2 squared, which is 13. It means my R is the square root of 13. So there is nothing about the R. And now the theta. And before you write it, let's talk a little bit about what difficulties we're going to have, not difficulties, what's happening with theta. So let us use tangent theta. I'm going to use tangent theta because that's what you guys are telling me. Tangent theta is y over x. So let's see, tangent theta is minus 2/3. Okay, now, and let me use tangent inverse of theta. Okay, so plug it into my calculator and I find tangent inverse of theta. Now, when I find tangent inverse of theta, my calculator is going to give me minus 0.588. All right, now, I mean, you guys plug it in just to make sure. The calculator is going to give me a negative number because tangent inverse is by definition the angle between minus pi over 2 and pi over 2 whose tangent is minus 2/3. So the calculator gives me the angle between minus pi over 2 and pi over 2 whose tangent minus 2/3. Now, is my theta equal minus 0.588? This is my theta?
No, it's not.
No, it's not. Because which one the calculator gives me? Let's watch the picture. If I take the point right there, this point here, totally reflection, it means that this is 3 and this is minus 2. Now, if I take this angle, let me call this angle beta, for example. What's the tangent of beta? Is it the same thing as tangent theta? Is the tangent of beta the same thing as tangent theta? Yes or no?
No.
Yes or no?
No.
Yes or
Yes.
no?
Yes.
Yes. Why yes? What's the
Because
tangent?
one of them's gonna be negative and the other one's gonna be positive.
Right. No, both are going to be negative.
Sure.
What's the tangent of beta? Minus 2
I mean,
divided by 3.
it's X and Y, yeah.
What's the tangent of theta? It's the y over x. It's minus 3 divided by 2. So those two angles have the exact same tangent. The calculator will give you that one. Because those two angles, the calculator doesn't give you all possible angle. The calculator will give you one angle whose tangent is minus 2 over 3. It will give you the one between minus pi over 2 and pi over 2. It will give you that one. So that's the calculator. This is the minus 0.588. This is the one. That's the one your calculator is. But that's not my theta. What is my theta now? Use the picture. Tell me what my theta is.
Isn't it pi minus?
Right.
minus
This is the theta. It's going to be pi minus 0.588. That's why I told you to use it with a lot of care. And that's why I told you have to use the picture. Because if you use your calculator and you plug minus 0.588, it does not agree with my picture. Because theta is not minus 0.558. So what's happening is that that's the one your calculator is going to give you. It's the one between minus pi over 2 and pi over 2. Now you look at your picture. So that's what the calculator gives. Okay. It gives you that angle. Then you say, but that's not what I want. This is the one totally symmetric because this beta and theta have the exact same tangent. That's the one I get from my calculator. The one I want, I had to take the pi to it. So that's exactly what my pi would be. So my point is going to be square root of 13 and pi minus 0.588. Okay. So if you want to use the tangent, that's how you have to do it. You have to be very careful which quadrant you are and how the picture is working. Now, if you don't want to use the tangent, remember, this is trigonometry. It means what I want is I want this angle theta. So another way you can do it, or I don't want to confuse you, but honestly, I want you to be very flexible with that. Or you can do the following. You say, okay, I don't want to deal with this negative stuff. So this is the theta I want. I said, I don't want to deal with negative. What I'm going to do is I'm going to take, let us say, this angle here. I'm going to take this triangle, move it to the side, and find this angle. Let me call it alpha. So I pretend I'm doing pure trigonometry. I have the alpha here. And from here to here, I have 3. From here to here, I have the 2. Pure trigonometry. I find the alpha, and then I take pi minus alpha. So I can, or you can just forget about the tangent, just use pure simple trigonometry. Go after this angle because it's an acute angle. So it's easy to work with. So it's not obtuse like before. And then you can look at this. You say, okay, if I look at this picture, the tangent is 2/3. It means the alpha is positive. So that's the 0.588. So my theta is pi minus alpha. It means pi minus 0.588. So of course, we're getting the same answer, but you can do it really any way you want. Okay, so if you use the tangent, y over x, you have to be very careful. You may need to add the pi. If you don't want to deal with negative tangent, you do a little bit of trick. You isolate this triangle, you find it, and then after that, you go after your theta. So be flexible with the theta when you're going to polar coordinate. Be very flexible because it's trigonometry is really nothing deeper than that. Okay, questions before I move on? Right. So this is how we move backward and forward between those two set of coordinates, the polar and the Cartesian. Right. Now we're going to start for the last few minutes we have. We're going to start talking about sketching in polar coordinate. So today we'll do the easy stuff, and tomorrow, a little bit harder, but nothing really hard. So my question is fairly simple. Sketch all points whose polar coordinates satisfy the given condition. So I'm going to put condition on the polar coordinate, whose polar coordinate satisfy the given condition. Okay. All right, so I'm going to sketch all the r theta such that the r, let us say, equal to 4. Okay. So I want to sketch all the points that satisfy the given equation, r equal to 4. What do I get? So basically here I'm looking at all r theta, all the points such that r equal to 4. That's really the way you look at it. So what do I get if I do that? What are all the points that satisfy this condition? Back to you. If I take all the points whose polar coordinates satisfy r equal to 4, what do I get? It's not a hard question at all. I get a circle with radius 4. Absolutely correct, because I'm looking at all the points that set r equal to 4. R is, that's a positive number, is how far we are from the origin. So I'm looking at all the points who are 4 units away from the origin. So all the points which are 4 units away from the origin, this is nothing more than the circle whose radius r. And this is not particularly great circle. Okay, so it's a circle of radius r, of radius 4. Okay, so if I express points in polar coordinate, it's very easy to represent a circle. If I want to represent a circle in radius r, radius 4, I tell you, okay, this is all the points whose polar coordinates satisfy r equal to 4. So r equal to 4 represent a circle. Now in Cartesian, the equation of the circle will be x squared plus y squared equals 16. So in Cartesian coordinate, this is the equation of a circle. It means this is the relationship between the coordinate of every point. The Cartesian coordinate is x squared plus y squared equals 16. That's in Cartesian. In polar, what characterizes those points is that the r is equal to 4. I hope B would be a little bit easier. Find all the points r theta such that theta is pi over 3 and r positive. So it means I want you to sketch all the points such that the theta is always pi over 3. It means I want to sketch all the points that has the form r pi over 3 with r positive. These are the points I'm interested in. Okay, back to you. What do we get? Anybody?
Would you just get a line that keeps going?
We get a line. Let me take r positive. Yeah, we get a line because all the point has, the angle is pi over 3, but r can change. So if r is 0, I get this point. If r is 1, my angle is pi over 3. So here I'm getting the point 1 pi over 3. If I want 2 pi over 3, I get this point, 3 pi over 3. So the angle is the same, but r can take any value. So I get this ray. Okay, so theta equal pi over 3, that's really the picture. So this line, I mean this half line so far, the one I'm drawing, is the line theta pi equal pi over 3 and r positive. So in polar coordinate, this is the line. In Cartesian, you have to find the equation of a line. So it's very different in Cartesian. In Cartesian, it means find the equation of this line. In polar, it means that's the line theta equal pi over 3. Okay. All right, I think I'm out of time. Tomorrow, we're gonna keep working along the same line. We're still gonna start sketching in the sense that we're gonna have curve where you have an equation on the polar coordinate, on theta and r, and you have to sketch all the point r theta that satisfy the given condition. All right, so I'll stop right there. Some of you are not doing the homework. You guys are behind on your homework. Please do them. You don't have a lot of time to wiggle. You have to learn this material, right? Okay.
Sometimes there's like